Okay, this question says, a particle moves along a horizontal line starting at a fixed point A. The velocity v of the particle at time t is given by v of t and then this equation here between 0 and 5. The following diagram shows the graph of v. So we've got our graph of v here. Now, it says that there are t-intercepts at 0, 0, so the t graph crosses here and here at 2, 0. Then it says find the maximum distance of the particle from A during the time between t is 0 and 5 and justify your answer. So first thing we need to do is to work out the relationship between this graph, which is the velocity, and the distance. So if I do a little sketch here, this is just going to do the distance here. So we're going to start off at some point here. This is the start. Now, as we start here at t is 0, our velocity is negative, which means our particle will be moving away from the start, and this here, the point, the velocity will be the biggest it is, so it will be going fastest, and then the velocity will come back towards 0, and then the velocity will start again in the opposite direction. So between this point here, t is 0 and t is 2, our particle is going to be moving away from the start, first of all going slowly, getting faster, and getting slowly again and stopping, which will be this point here. So this point here will correspond to a distance, a displacement down here. So when here it's going to be when t is equal to 2. Alright, so it's going to go along here, getting faster, fast, and then slow down again, and then arrive here when we're here. At this point, the velocity's changed direction. The velocity is now positive, meaning the particle will now start to move in this direction, and then it's going to go further away. Oh, sorry, it's going to go back towards the start here, like so. And at some point here it will get back towards the start, so round about here, when this area and this area are the same, and then it will move the other side of the start, which will be when we get to the end of this graph here. So it's going to start at the start, it's going to go along here, stop, then come back again, go past the start, and then it will end up over here somewhere. So over here will be when t is equal to 5. So if we're looking for the maximum distance, we're going to need to work out how far away it is at t is equal to 2, and also how far away it is at t equals 5, and then see which of these is the larger. So the way we can work out how far away it is at t equals 2 is going to be to find the area under the curve, this area here. Now that area is going to be the distance travelled, or the displacement, or, distance when t is equal to 2, and that's going to be the integral of v dt between 2 and 0. Now, to find the distance it is away from the start when t is 5, we're going to need the whole of this area and then add the whole of this area. So it'll be the whole of this area and then add the whole of this area. So basically it's going to be the entire area up until the 5. So it's going to shade that different colour. So for the other one, it's going to be that area there. So this one is going to represent the distance when t is equal to 5, and that is going to be the integral of v dt between 5 and 0. So we can work out both these integrals, this one between 0 and 2, and then we can work out this integral between 0 and 5, and we can see which of these is larger. So will it be the one where it's gone from t in one direction, or will it be when it's come back again past the start and gone out the other side when t is equal to 5. So we need to work out the values of both of these integrals and see which of these is larger. So the way we're going to do this is use your graphical calculator, is to put the equation in here, this one, and then integrate it between the limits of 0 and 2 first of all, and then between the limits of 0 and 5, and work out this one and compare the two. So I've used Wolfram Alpha for this, so it's similar to putting it into your graphical calculator. So you can see here I've entered in the equation, and then it's said here the definite integral between 0 and 2, and it's told me that is negative 2.28. The reason it's negative is because it's below the curve. So we just want this area here to be 2.28. So this one, the red one, is equal to 2.28. And then if I did the same thing for the other integral, You can see here I've got this area and then this area together, and it's worked them both out together, and it said this one is 1.56. So this area here, the blue one, is equal to 1.56. Now clearly the 2.28 is bigger than the 1.56, so it went further away on this side. So the blue one here is 1.56 meters, and the red one is 2.28 meters. So the answer will be maximum distance is equal to 2.28 meters from the start. Let's let f of x equal this function here, and it says the following diagram shows part of the graph of f. So we've got a graph here. It says there are x-intercepts at x equals 0, so it means the graph cuts the x-axis here, and also at x equals p, which is here. It says there's a maximum at a where x is equal to a, so this point here, and the x value is that one, and a point of inflection at b where x is equal to p. So this is the point of inflection here, x equals b. Point of inflection means that the curvature changes. So you can see this part of the graph here, the curve is like a happy face, and this part of the graph, the curve is like a sad face, and the point of inflection is where it changes from being happy to being sad, so where the curvature changes. Alright, part A says find the value of p. So the way we would do that is we would just plot this function in your graphical calculator and then move the cursor to point P and then read off the value. So I've plotted it here, plot this one, and then it's given me the graph, and then I can just read off that value there, which is 2.73. So P is equal to 2.73. Alright, next it says write down the coordinates of A. So depending on how your calculator works, you could probably also just read off where the maximum is. It might be a little bit hard to get exactly on the maximum. So perhaps a more sensible thing to do is at the maximum value here, we should know that the differential would equal 0. The rate of change is 0. So if we work out what f prime is, we could then plot that and then see where that crosses the axis. So what I'm going to do is just differentiate f and work out what f prime is. So f prime of x would be, we'd multiply 4 by this minus 0.5 to give us minus 2, and then reduce the power by 1. So that would give us minus 2x cubed. And then we do the same thing here, we'd multiply the power by the number here, so that would give us 6, and reduce the power by 1, so that would become 6x. And then the last one would just become 2, because x to the power of 1 would become x to the power of 0, which is 1. Or we just drop the x, which becomes 2. Okay, so we could then plot this function and then look for the point where it crosses the y-axis where this becomes 0. So what I've done here is plotted this function like that, and you can see it crosses the axis here, and then we read off that value of x, which is 1.88. So here, this is equal to 1.88. Then, because it actually asks for the coordinates of A, I would need to then place the 1.88 into this function here, substitute in for x, and then work out what the y is. If I do that, I would get 8.12. So coordinates of y of A are 1.88 and 8.12. Alright, so next it says write down the rate of change of f at A. So I've kind of talked about this here already. It said that here, because it's a maximum, f prime of x will be equal to 0. So I'm going to write that on here. So at this point here, f prime of x is equal to 0. So that f prime is the measure of the rate of change, is the differential. Differential is the rate of change, the same thing. So f prime is equal to 0 at this point here. So rate of change here will be equal to 0. Alright, next it says find the coordinates of B. So this is a point of inflection here. So you should know also that at the point of inflection, f double prime is equal to 0. Alright, so second differential is equal to 0 at a point of inflection. So we can do a similar method to what we did here. I'm just going to differentiate this again. So I can say that f double prime of x is going to equal, so I would do 3 times negative 2, which gives me negative 6, and then reduce the power to be negative 6x squared. And then the 6x will become just 6, and the number constant will disappear. So that would be a second differential. If I wanted to, I could plot the graph of that and in the same way look for where it crosses the x-axis. Or this is a reasonably straightforward one, so I could just set that equal to 0 and solve it algebraically. Or I could even use the graph and then look for the point where the maximum is. So depending on how your calculator works, if you can easily work out where that maximum is, you could do it that way. Or the way I'm going to do it here is I'm just going to set this equal to 0. So I'm going to say that negative 6x squared plus 6 is equal to 0, and then rearrange that, so I'd get 6x squared is 6, x squared is 1, and then so x is 1. Alright, in theory it could be plus or minus 1, but we're only interested in between 0 and 1. Here we're looking for the value of b is going to have to be 1. So x would be 1 at this point. And then what we'll do is substitute the 1 into this equation here to work out what the value of y is. So if I do 0.5 times 1 to the power of 4, it's just going to give me minus 0.5, and then plus 3, so that's going to be 2.5, and then plus 2, so that's going to be 5.5. Is that right? It should be 4.5. It's minus 0.5 plus 3, so that's 2.5 plus 2 is going to give me 4.5. So b is at 1, 4.5. Okay, next it says find the rate of change of f at b. So like I said before, rate of change is equal to f prime. So f prime is the rate of change. We know at this point x is equal to 1. So I would just need to substitute 1 into f prime. So here I'd have negative 2 plus 6 would be 4, and then plus 2 would give me 6. So this one here, I'm finding f prime of 1, which is equal to 6. Alright, finally it says that R be the region enclosed by the graph of f, the x-axis, the line x equals b, and the line x equals a. This region R is rotated 360 degrees about the x-axis. Find the volume of the solid formed. Alright, so we're talking about the region here between the line x equals b and the line x equals a. So we're talking about this region here. And that is going to be rotated 360 degrees around about the x-axis to sort of make a kind of sort of 3D lampshade kind of affair. So it's going to sort of look like that. I have a circle around there, and it's going to be, that's a terrible drawing, sort of like that. You should get the idea. It's going to be a three-dimensional shape. Anyway, what's important here is that we know that when we work out the volume of a 3D shape, the volume should be pi times the integral of y squared. So the volume is going to be pi multiplied by the integral of y squared dx, and then putting in the limits. So we know that the limits between x is a and x is b. I've written that in the wrong place there. That 1.88 should be here. Okay, that one was 2.73. Okay, so the limits that we need here are 1.88 and 1. So I just need to evaluate this integral here. So I've got y squared here to integrate with respect to x and multiply by pi. So I can just put that into the calculator. I don't need to work out what y squared is. I can just put this function here and then square it, and then evaluate that integral. So what you can do is stick that into your graphical calculator. I've stuck it into Wolfram Alpha here. So this is my integral between 1.88 and 1, pi times, this is the function y squared dx, and that gives me 129. So the answer for this is 129.